Let me ask you, Mr. Melzer, in your position as the chairman of the Platform Industry 4.0, which is the most renowned committee of its kind in Germany, where is the journey heading?
Well, the journey is clearly heading, as we experience in everyday's life, to more digitalization, we get more software, and we get more a data-driven economy. But let me go one step back. What's the Platform Industry 4.0? It's actually a public-private partnership initiated by the federal government of Germany and combines governmental activities with about more than 150 companies and 600 participants voluntarily in different groups working on concepts, examples for Industry 4.0, and thus serving for all companies in Germany, Europe-wide, worldwide to develop that concept further. And Industry 4.0 is now the framework or the word for the next step in industry. And this is like the digital made in Germany. We're very proud of that, to push that limit further and further. We developed the framework last year, and in this framework we have three main pillars. One is sovereignty. And one example is the Gaia X project, where German government was driving, but industry was very much supporting a digital platform where data is sovereign. It means everyone can precisely describe where's the data, what security level, what happens with the data. That opens up new possibility in vertical digitalization. The next step is interoperability. Difficult words. And this is difficult word, but easy thing. How can things work together across industries? And we have a very fragmented industry in Europe, so it's very important that the systems can talk to each other. And different concepts are around, and the most interesting one, derived, very practical one, is the digital plate, where you have all the information of a product in a digital form and don't have any printed information. Like for that product, we have still a lot of printed information which we deliver, which then will scrapped afterwards. And we as Festo, for example, could save about 150 tons of paper a year if you fully go for a digital plate. And last but not least, it's sustainability, resource efficiency. How can digitalization help on resource efficiency?
And what kind of ways can we imagine that?
Well, one is here. That's a valve terminal, but it's a very intelligent one, Festo Motion Terminal, where we have controllers, sensors, and can control the pneumatics in a very different way. That means we can demand controlled airflow, and that's a much more efficient way. It's energy efficient and a much better controlled theory for moving things.
Thank you. So let's have a look at this nice little machine here. So, Mr. Stemler, how does this small valve terminal help your customers to produce more energy efficiently?
Well, there are several different ways how we help the customers with this product to save energy. The first I want to mention is that we are able, Mr. Melzer, you said that already, that we are able to reduce the energy consumption because we can control in a demand-responsive way. So usually, when we talk about the pressure level in compressed air systems, we have a pressure level of 6 bar. Combining 6 bar with a certain size of a cylinder means that we can lift a certain force. In that case, I can show you that in that example that I can lift this weight with 6 bar, and the standard way would be to transport it down with 6 bar again. I have the possibility with a motion terminal that I easily can reduce the pressure to 3 bar. In that case, 3 bar are enough to lift that load and to transport it down again. I will just shortly present that even 3 bar are enough to lift the load and to bring it down again. We can go one step further. I lifted it again with 3 bar. We now can take advantage of the gravitation energy and lower the pressure to a certain minimum. Let's say 1 bar, for example. I can reduce the pressure to 1 bar and retract the cylinder movement and move down. So with this, I am very easily able to reduce energy. The first step, lowering it to 3 bar, was approximately a saving potential of 50%. With moving down of approximately 1 bar, I save up to 60% and more of energy. So this is quite a large number. That is interesting. We are able to reduce the pressure in standard operations as well. So with a standard operation, a manual adjustment also leads to the same result, so that we are able to reduce the energy level. But then you need a personal adjustment. People need to adjust the pressure. In that case, this is time consuming, and as it is not economical at the end, no one is doing this. With a motion terminal, we are digitizing this. So we make it very, very easy for the customers to lower the pressure, and the barrier for saving energy is much lower than compared to standard technology.
So you see, actually, sorry,
Please.
just want to add to that, because you see, digitalization helps. We don't need AI for doing that. Digitalization helps to energy safe design our products and the applications for that. And that's the key thing. What we need for that, like also in the IoT gateway, we need a controller, we need sensor, and we need data interface. And on top of the data interface, we can bring the data also up to a cloud or on the premises and dashboards and the customers.
So thank you for this great demonstration here. Do you have a concrete example for us for these savings?
Of course, we have one. We solved the solution in the tire industry, talking about the loading situation of a curing press. We have 2 pneumatic cylinders over there. And with exactly that effect that I was showing, that I lower the movement or transport the mass down with 1 bar, this led to a saving potential of 60% of the energy. It's not only energy saving we can address with digital pneumatics, we also can shorten the process time. So this is what opens different doors in the digitization of pneumatics. Well, when we talk about energy-saving products and in combination with dashboards as well, it's not only the Festo Motion Terminal that has to be mentioned, it's the Z2m Module as well. So the Z2m Module is a very intelligent device that is usually installed at the front end of a machine. We have sensors for pressure and for flow integrated in this module, and we are able to interpret the data to derive information and derive actions, actually. So with this, we detect the still stand, the idle mode of a machine, and this module is deciding to then start at energy-saving mode. We can detect leakages as well, and then the customer is able to derive idle states where he can repair. So we are delivering a leakage rate information with colors like red, yellow, and green. And based on that, the customer can decide when the machine stops and when the machine starts again. So with this, he increases the whole productivity of his factory. And of course, he saves energy by lowering the leakage rate.
What do you have in mind, Mr. Melzer, if you're listening to him?
When you have in mind that this is very important, I mean, this gives a big push in energy saving, and this is the term of these days. I mean, we calculated that just a device easily can save up to €100 just for one device from one example machine. If you scale it to a factory, that's massive. And this is what we see currently as a pull in the industry. For example, automotive industry wants to know, or other industries wants to know what's their CO2 footprint. And what are the energy costs? So here, the digitalization helps us, and it also helps us with data transparency. We can get the data out of that, and we can use this in examples like Z2m cases, where we control the airflow and can shut down the airflow if the machine is not working anymore, and it starts up again. Like a soft start or like a standby button in a TV. Things very well known in typical industries, but fairly new for pneumatics, and brings pneumatics to the next level, to digital pneumatics.
So good point you're doing there, and especially on the subject of AI as well as energy efficiency, we received a lot of questions from journalists. So let me pick out one of them. Is AI, Mr. Melzer, is AI already being used in the area of energy efficiency in production? What do you think?
We are clearly on the way. I mean, it's very obvious. I told you that we bring the data up to the cloud or to the dashboard, and then we can bring in AI. Then we can bring in AI optimizing energy streams, finding abnormalities. The other example is just here, right there. I mean, Marcus Stemler clearly showed how he changed the pressure and still the device is working. I mean, an AI system can learn that. and can learn what was a constrained learning by given times or different applications. What's the optimum pressure level for moving up or down, even time dependent. So this will be then an optimized movement plus minimizing energy usage. So we see clearly this is the road where we're going.
So Mr. Stemler, if I have it right in mind, in your opening statement, you also hinted in the direction some kind of energy efficiency consulting.
That's true,
that sounds
exactly.
interesting.
Exactly.
We'd like to know more about it.
Well, we have our energy saving service. So this is the service's name in our portfolio since approximately 15 years. The guys from that saving service, they visit yearly approximately 450 large factory buildings, where they analyze the whole compressed air system, not only the products where we are in, but it's the whole compressed air system. So they focus on weak points inside the factory for compressed air generation, compressed air treatment, and the usage in the machines. This is one aspect of the energy saving services. The other one is application engineering. So many use cases in machine builders are about the question which kind of technology is the most efficient one. And it's actually not the case of a technology question, which is the most efficient energy that has to be used for an application. It's an application question. So there are applications where electric cylinders are more efficient than pneumatic cylinders, and others where pneumatics are more efficient. For example, when you want to clamp something or when you want to hold a certain load, pneumatics are more efficient in that. And because this is a very difficult question, our saving service guys, they support the customers in consulting a very technology-independent way. So they help the customer to find the best solution for their application.
And precisely this differentiates us in the market. Festo is the company delivering cross-technology possibilities. We have knowledge in mechanics, in pneumatics, and electric drives. So we can combine these things to the optimum solution. We don't have to drive electric drives because we just have them. If for many cases, for small movements, pneumatics are superior, we offer that. This is the advantage for Festo in the market. In talking about electrical automation, let me mention one thing which is, I think, very interesting, and we also show in the virtual fair. This is the simplified motion series, as we call it, where let's say pneumatics meets the electric world, where we have small drives in a very simple form, easy to install, easy to commission, but with the full functionality of an electric drive, communication, I/O link, can get all the data out, but a simple drive combining nearly the best of two worlds. And it's an interesting approach and strengthens our position for a cross-technology offering towards the customer. And all of that can be seen in our virtual exposition.
So it's great to hear that you're saddle-proofed in all kinds of technologies. And it's great to hear also, and it's kind of an invitation really to join this virtual exhibition because you're showcasing a lot of things there.
Precisely. The best solution always depends on the application, and this particularly applies to energy efficiency. We will show this quite strikingly at our virtual fair, where we have a simulated pressing process. Once we have a pneumatic, the other one an electric, or a servo pneumatic. And depending on the application, the one or the other is superior. And it's very difficult precisely predict beforehand without knowing the application. It's impossible. But with the application, we can predict what's the right way. The other example is the Festa Balancer, and we see that in a video right now, where we lift the device, and the Festa Balancer can lift a weight up to 1,000 kilograms or a ton. And when you want to hold the device in a position, then pneumatics is superior. Like in an automotive plant mounting wheels, you lift off the wheels, then you mount them, because no energy supply is necessary by holding. Versus electric can be superior when it's just moving quickly from point A to B or fast from point A to B. Their electric solutions is much superior on energy saving. So it depends on the application, and the system design is crucial.